Hello, my name is Ed Chapman, and this slideshow will cover the scientific method of investigation. Science is a tool invented by people to answer questions about the world around them. Science provides answers for why things happen, or how things happen, or when things are going to happen. And people are always more comfortable when questions are answered and not just out there hanging. Before science, people didn't have a whole lot to rely on. They just had their own observations or what somebody might have told them or what a group of people might believe. But science is a little bit different. Science demands that explanations be observable and repeatable and measurable. So science is a tool, like this screwdriver, that's best for some things but not all things. Science, of course, is a product of our culture. It's something that was made by people and used by people. It's not something you're going to find in the woods or in the ocean just laying around. It's a tool invented by people. And it's based on, the most important thing is observation. Science is based on what you can see, touch, smell, hear, feel, measure in some way. If something isn't observable, then it's going to be very difficult for science to answer questions about it. And second of all, science is based on the testing of hypotheses, and this is done using controlled experimentation. All right, science is collaborative. Science is something that requires data to be shared. You can't expect a scientific idea to be accepted if you're not willing for your data to be exposed or talked about by other people. Data has to be shared. Science doesn't keep secrets. Scientists get together all the time and discuss and evaluate each other's work. That's a polite way of saying that they argue. They fight. Scientists have ideas that are very near and dear to their hearts, and sometimes they get very upset when people challenge their ideas. But science always has to advance. Theories never get to be set in stone and remain unchanging forever. New information, new observations are always coming in, and sometimes this requires theories to be changed or sometimes completely thrown out. The history of science is filled with examples of very well accepted theories that are completely gone now, no longer useful because they've been replaced by better explanations for newer observations. The scientific method is a process based on inquiry. You ask a question and then you try to find an answer, but you use a set of steps or you follow some rules that leads to the answer that you're trying to figure out. You're beginning with a question and you're ending with an answer. So you have an idea or a question, you figure out how you're going to test it, and then you make some observations to test your experiment or test your idea. The steps to the scientific method are pretty straightforward. You've got to have a clear understanding of what you're trying to figure out. You've got to collect information before you start to figure out what's already known. Then you've got to write a hypothesis, your predicted explanation for what you think is happening. Then you've got to design your experiment around the hypothesis to make sure that what you're doing is actually going to test your explanation or test your hypothesis. Then you're going to do your experiment over and over again and collect data, and you're going to compare your data sets to see if everything's working properly. There's always things that go wrong that have to be accounted for and fixed. Once you get all your data, you're going to write a conclusion, and based on your data and your analysis of your data, you're going to decide whether or not your hypothesis is acceptable or whether you have to reject it. And finally, you're going to refine your experiment, make changes to reduce errors, things you didn't think about when you started. You're going to repeat it, and you're going to share or collaborate with other people. And hopefully, your answer will be the best answer, and it will get to become a theory. So what is a hypothesis? Well, a hypothesis is an untested explanation, or the cause you think is the reason why something happens. It's a prediction. Most of the time, hypotheses can be written as if I do something, then something will happen, or what we call the if-then statement. So the way it works is you have all of these possible causes that you think one of them is causing an effect. And the job of your experimentation is to eliminate all the other causes until the one left behind is the only possible cause for the effect that you're seeing. And if you've done a good job designing your experiment, you'll be able to say that this cause has this effect. Now what often happens is there's an unexpected cause you didn't think about that's at work here, and you have to start all over again. So what is a controlled experiment? Well, a controlled experiment is based on a hypothesis, and it's going to test one hypothesis at a time. The causes in the previous slide can also be called variables, and these variables are quantifiable, observable, and repeatable. Quantifiable means they can be represented as numbers or measurements or counts, and observable means that people can see them and you can produce them on demand, and you can reproduce them over and over again. It's repeatable, and each time you repeat it you get similar results to the previous trials. So you take your hypothesis and you break it down into if, then. Okay, if I do this, then I'm predicting something will happen. And the variables that we're working with here have different names. The independent variable is the variable that you must control. Okay, and your dependent variable must be something that you can measure. And the constants are all the other variables, and you're not going to allow them to change. You're going to keep them the same. So if we apply the idea of these variables to the hypothesis, if I do something, which is the independent variable, what you're controlling or what you have the ability to change, then what you predict is going to happen. And what happens has to be measurable. So you have your independent variable following the if word and your dependent variable following the then word. So together they build your hypothesis. What's a theory? Well, a theory is a tested explanation for an observation. It's supported by many observations and many experiments repeated over time, and it's consistent. And as new information comes in, though, the theory has to, as I said earlier, must be adjustable, and it can be thrown out at any time if the data set becomes so against it. Often hypotheses grow up into theories once they're accepted and tested from multiple angles. People frequently use the word theory wrong all the time. Some things I've heard frequently is, I have this theory about something. No, what you don't have is a theory. What you have is a hypothesis. You haven't tested it yet. And a popular one right now is this idea that global warming is just a theory. By saying that, you're implying that all the information that's been gathered over many, many years of climate analysis hasn't been tested. Well, it has been tested. By something being just a theory in science doesn't mean it's somehow not been tested. And this confusion of a theory with a fact. In biology especially, there are very few absolute facts, but there are lots of theories. We accept most scientific theories as being factual until something really radical happens. For example, gravity is a theory, the theory of gravitation. We can't see it, we can't touch it, we can't feel it, but we can measure it, and as far as we know, it always works the same way in all places. So gravity technically is a theory. The atom is a theory. No one actually can look at a single atom. We don't have that technology. But based on what atoms do and how they interact with each other, we've come up with atomic theory. And it's changed a lot over the last 150 years, but we still can't actually directly observe individual atoms. So I hope this slideshow has given you a good idea about how science works and how science is different from the other ways that people answer questions about the world around them. Scientific investigation never ends. It's an endless cycle. And the beauty of it is, each time you figure something out or each time something is discovered, it creates even more questions. So it's not like all the good science has been done. New technologies constantly being invented and opening up whole new areas of investigation. For example, the microscope. Nobody knew about bacteria until someone discovered a tool strong enough to actually see them. So new technologies are always opening up new areas. So don't get discouraged and think all the good science has been done. That certainly isn't true.